the advantages of these decoders, right? What is one of the advantages of decoders? Can we able to implement any kind of logic circuits? Yes or no? We have seen various kind of examples, how to implement various kind of Boolean function, right? So that is one of the advantage of decoders. Similarly, we can able to perform various kind of conversion sum. So this is also one of the advantage of decoder. Like for example, I want to convert a number binary to octal. Binary to octal. See, conversions means all kind of conversions are not possible. There are some kind of conversions which are possible through decoders. Some kind of conversions which are possible through encoders. Some kind of conversions which are possible through multiplexers, like that, right? So some conversions are possible here, like binary to octal, BCD to decimal, like that various kind of conversions are there. Those will be supported by decoders. For example, I want to implement through binary to octal. How we are going to do? So in octal, how many output lines are there? 8 output lines are there. Octal representation, right? So if you are going to have, so you can able to implement with help of 3 by 8 decoder. 3 by 8 decoder, right? So output is O0, O1, O2, O3, O4, 5, O6 and O7, and you are going to have inputs as I2, I1, I0, right? Meaning that if I am going to give 1 0 0 as input, what need to be my output should be produced 4, right? So I am going to give 1 0 0 as input. I am going to get the high voltage at which level? O4. So can I say it is binary to octal conversion? Yes. Right? So you can able to do that. So can you draw the truth table for this? If I am going to draw the truth table, I2, I1, I0 and O0, O1, O2, O3, O4, O5, O6 and O7. Right? Inputs are 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1. Okay now, if I am going to get 0 0 0 as input, what need to be activated? O0 should be activated. That's why I made here as 1 and all the remaining are zeros. Similarly, 1 you got 0 1 0 0 4 zeros. When you got 2, you need to get the output at O2. When you got like this, you need to make sure to write correctly. O4 is going to be activated. When you got 1 0 1 at 5th line, it is going to be activated. When you got 6 as input, 6th line is going to be activated, and when you got 7 as input in the binary format, you are going to have 7th line is activated. So this is the way you can able to draw the truth table, right? So for this, can we draw the circuit diagram? Can you draw the circuit diagram? What is O0? Can write O0 as I2 bar, I1 bar, I0 bar. Similarly, O1 is I2 bar, I1 bar, I0, O2 and so on. You can write for all the cases for the coming class and try to draw the circuit for this, right? So circuit how we are going to get? You are going to take I2, I1 and I0 and all the inputs will be get like this, right? Assume that it's a kind of 3 input AND gate, right? If it is 3 input AND gate, the circuit is going to be differentiated with 2 input AND gate, right? So 3 input AND gate, how we are going to construct with the help of 2 input AND gate? You require 2 AND gates, right? So basically, if you take here, this is 3 input AND gate. If you want to make it equivalent with 2 input AND gate, it should be like this, right? The resultant should be connected with like this. That is the difference between this one, right? So that's why I specifically mentioned here it as 3 input AND gate, because every time we are going to take 3 input variables. Right? You can draw this circuit diagram for the coming class. Okay. Similarly, you can able to do construction for BCD to decimal also. In BCD, what are the valid inputs? Valid inputs are ranging from 0 to 9, and output is going to produce from 0 to 9 also. Right? So you can do that for your example. Okay. Similarly, you can able to use this decoder for the purpose of parity checker. Parity checker. What is the meaning of parity checkers? Right, we can able to define whether it is an even parity or whether it is an odd parity, right? So even parity, for example, if I am going to have the inputs like A2, A1 and A0, all the cases 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, right? So if I want to say whether this input is even parity, what my output should be, right? So if I want to say that even parity, so is it like any kind of thing added here? No. So that's why I am making it as output as 0. And here to make it as even parity, I am going to add 1. Here 1, 0, 1, 0, 0, 1. Right? For this, can you able to draw the circuit diagram? If it is going to have 3 by 8 decoder, you are going to have 3 inputs A2, A1 and A0, and all the lines are going to be activated based on the requirement. So what are the values? 1, 2, 4 and 7. So for 1 you are going to get, for 2, 4 and 7, OR gate you are going to get, right? So now what is the output you are going to get here? Output you are going to get 1. For any one of these inputs, like if you are going to simply take 0, 1, 1, 0, 1, 1, which means that line 3 is going to be activated. Line 3 is going to be activated, right? So 0, 1, 2, 3. Line 3 is going to be activated, meaning that for the output, what is the value you are going to get? 0. Means that is it an even parity or not? The given input is already in even parity. If I am going to get the output 1, I can say that the given input is odd parity. So this is the way you can able to define the one of the advantages for the